Okay, so today we're going to learn about sets. So we learn about these sets. We'll just have a sort of revision by doing this question. So, so this question is kind of simple. So they have said to fill in the blanks in the following by using either the symbol this or this. So what is this symbol actually? So this symbol is called a subset symbol. So this is called a subset. Okay, this is how we use this, right? So let's just imagine that. Imagine your country. Let's say Sri Lanka. Okay, L is capital here, Sri Lanka. Okay, and let's say Colombo. So we can just say that. Okay, we can say that Colombo is actually a subset of Sri Lanka. The reason is because Colombo sits inside Sri Lanka, right? So it's actually a subset of. Okay, so remember that the subset symbol, the right side has the bigger one. I mean the thing which is enclosing the a smaller one, and in the left side we have the smaller one, which is Colombo. Right. So now what does this symbol mean? So this symbol, let's see. So this is called an epsilon. Okay, this is actually a Greek letter. It's called epsilon. Some people call epsilon as well. It's fine. So this is actually called a universal set. A universal set. Universal set. So what that means is that all of the sets are enclosed inside this epsilon. So that is called the universal set. Right. Now, using either symbol, subset set, or epsilon based on the information in the Venn diagram. Okay, so let's see. Now, the first one says that 4 and Q. First one says 4, the number 4 and Q. Right. So what do you think? So 4 and Q. So 4 is inside the enclosed Q, right? So let me zoom here. Let me zoom in here. So if we look at here, so actually the 4 is enclosed inside the Q. So Q is a bigger circle, 4 is inside P. So that means it begs the question. We can actually say that 4 is a subset of Q. Why is that? Just imagine Colombo is a subset of Sri Lanka, just like that. 4 is a subset of Q, right? Next question. Next question has 7 and Q. 7 and Q. Let's see. 7 and Q. Oops. Okay. 7 and Q. Okay, what about this now? Okay, where is 7 here? Okay, 7 is outside and Q is inside. That means there is no connection here. Is it? There is no connection. The third one has P and epsilon. Okay, right. Let's see. 7 and Q, there's no connection. So what should we say? Oh, that means this symbol is actually a printing mistake. This symbol is actually this, not a subset of. So it's actually a printing mistake. So we can say 7 is not a subset of Q. Not a subset of Q. Okay. What about the next question? Let's see. Third one, we have P and this universal set, epsilon. P and the universal set, right? Now, what do you think? The universal set is the entire the square box enclosure, and P is inside it, right? So P is here, and the entire box shape Venn diagram is actually outside. So that means that P is a subset of Q. Sorry, P is a subset of epsilon. So let's write that as well. P is a subset of epsilon. Okay. Fourth one, we have P and Q. P and Q. Oh, that's easy. So we can actually see that P is a smaller one, Q is a bigger one. So Q has the entire region here. So just imagine, okay, Colombo, subset of Sri Lanka, just like that. So P is a subset of Q. It's going to be like this. P is a subset of Q. P, Q, and we have a subset here. What's the next question? P intersection Q and blank P. That's kind of hard. Let's see. P intersection Q. How do you take P intersection Q? Okay, what do you mean by intersection actually? Intersection means that the common part, right? The common part. So here, the intersection of P and Q will be this part. Why? Because P and Q, okay. What do you say for Q? Q is equals to, okay, 1, 2, 6, 8. And we also have 4. The reason is because Q actually owns everything. Okay. What about P? What does it have? It has only 4 here. So what's the common number here? What's the common number? 4 is the common number, right? So P intersection Q is equals to 4. Okay, makes sense, right? So just like that, okay, we can just apply that and say P intersection Q and P. What do you think it is? P intersection Q and P. So P intersection Q is actually the same as P, right? Because P is actually 4 and P intersection Q is also 4. So if I am going to edit this, right? So P intersection Q, P intersection Q is also 4. P is also having the element 4. That means P intersection Q is equals to P. P intersection Q, P intersection Q is equals to P. Okay. Or else equals to, or we can say it as a subset as well, right? Because it is actually a subset here. My bad, we can say it as a subset. Yep. Okay, so that's the first Roman number, I guess. No, the part A is finished. Let's move on to part B. Okay, they have said to write NP complement. Okay, what's complement actually? What's a complement? Let's see. Now, we have boys and girls. We have boys, girls, and we have cats. And yeah, we have dogs as well. Okay, that's not a rat, that's a dog, right? Okay, now there are 7 boys, there are 6 girls, and there are 2 cats and 2 dogs. Now, what if I say you boy complement? What if I say a boy complement? Okay, I'll just say boy. Okay, you must find the boy, but you must complement. So, okay, first of all, let's say boys. Okay, how many boys are there? There are 7 boys, right? Good. But if we say a boy complement, that means we should find the number of all the other people except for boys. Does it make sense? So if you take a boy complement, we must take all the other people except boys. That means it can be girls, it can be cats, it can be dogs as well. So 10. Okay, right. So that simple example is over. Now let's look at here. So write NP. So N means a number of, right? So They're asking us to find right NP complements. Okay. Okay, that's easy. So what we should do, we can just count the numbers, how many numbers are there. That's all you have to do. That's all you have to do, right? So NP complement is equal to, let's see, okay, a P, this is P. So we don't want P. We want the P complement. Oops. That means we should have all the other colors except for P, like this. All of these except P. So if I'm shading this here, right here, so the shaded numbers should be considered except for P. So P is not considered here. Right, let's see. We have how much? We have one. Okay, now let's just clear this. One, we have two, three, four, five, six, seven, eight. Yep, we have eight. We have eight numbers here. Nice. What about the next one? The next one says us that how many subsets does Q complement have? Write four of these subsets. Okay, what did the question mean? Right? How many subsets? Okay, subsets. Okay, does Q complement have? Okay, what is Q complement? Stuff that are not Q, right? Stuff that are outside Q. Let's see. So stuff that are outside Q can be said as stuff that are outside Q are these. These, this, coloring. So because P is a part of Q, because Colombo is a part of Sri Lanka, I mean, because of that, they are omitting the P as well because P is also inside Q, right? Now, what are they asking? What subsets does Q complement have? Right, four of these subsets. Okay, they're actually simply asking us, what are the elements inside the Q complement? The reason I'm saying this is because, okay, let's say Q complement, and let's say 9. How do you say it as? 9 is inside Q complement, right? So we actually write like this. So actually, in another sense, this is a subset. This is a subset scenario here. And it goes on for 7, 9, 3, and everything as well. If I erase this here, to make a bit of room to make it a little bit more clearer. So that means we have all of these subsets here. 7, 9, 3, 5 are all subsets of Q complement. This makes sense. 7, 9 Q so that means write four of these subsets. So we can actually write subsets of Q. We can write four, sorry, 7, 9, 6 times 7. So we can write as 7, 9, 3, and 5. This is kind of like a tricky question actually, because they are not actually directly asking us to write the elements of Q complement. They're actually saying us to write the subsets of it, but both are the same thing in this scenario. Right, let's go to the C part. The C part here, the most awaited one here. Okay. The C part is saying that, okay, the universal set is counting numbers from 1 to 20, blah, blah, blah. Okay, we get it. A is going to be the multiples of 3 from 1 to 20, and B is going to be multiples of 2 from 1 to 20. Okay. List out the elements in the above three sets. Okay. But before we, yeah. So first of all, let's do the first one. So what are they saying? They're saying us to find, list out this stuff here. Wait a second, I'll just move this right here. Yeah, better. Now, let's list out this stuff here. So equals counter numbers from 1 to 20. We have what? 1, 2, 3, 4, all the way to 20. All right, finished. Oh my God, that's a big one. So this is epsilon, which is going to be the entire universal set here and the numbers inside those universal sets. Okay, I know what is going to happen now. Okay. A is going to be write all the multiples of 3 from 1 to 20. Okay. Okay, so 1 to 20, right? So 3, 6, 9, 12, 15, 18. B is going to be write the multiples of 2 from 1 to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, but now what are they asking us? They're asking us to represent the above sets, okay? I've heard it. So represent the above sets in a suitable manner in a Venn diagram. How do we do that now? Let's see. Right, so now I'll just maximize this here. Oops, yeah. Maximize this thing and move this right here. Select this, make it smaller. Better. Now what I'll do is I'll just draw a Venn diagram here. So it's easy peasy. What you can do, you can just choose this option here to write straight lines here. Write straight lines. So we have this. Okay, and then we can draw two circles here. Two circles. Two circles. Yeah, perfect. Now, let's see. So let's name this stuff. So let's name this guy as A. Let's name this guy as B. And let's name this as the universal set. Right. Now, just list out this stuff. Okay, first of all, before doing this, actually, it begs the question, okay, it's very safe actually to analyze A and B. So what are the common numbers in A and B? Common numbers. Okay, 6 is common here. 6 is common. What about this? 12 is common. 18 is common. What else? That's all, right? Okay, so that means that in this intersection part, in this part, actually, in this part, the common numbers come in. So we have the 6, we have 12, we have 18. And simple, the other numbers you just fill in here. So A we have 3, 9, 15. Okay, so no, there will be no commas here. And here will be 2, 4, 8, 10, 14, 16, and 20. And the others, 2, 3, 4, 5. Okay. What about the others? What about the others? Come on. Let's see that what are not common here. So 3, 6, 9. Okay, these are all gone. These are all gone. So, and we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, now what are the remaining ones here? So outside this A and B, we have 1, we have 5, we have 7, we have 11, we have 13, we have 17. Oh, okay. All are prime numbers here, don't you think? All are prime numbers here. Right. What's the question say after this? Right. So just note down this, this Venn diagram, and let's go to the next question. So now I think we don't need this part. We don't need this part. Okay. Now, write the elements of the sets. Write the elements of the sets given below using set number 2. Above. Okay, that means they are simply saying us to write, use this Venn diagram and find these. Okay, well, the first one is going to be A. Okay, that's simple. Write the elements of the sets given below. So A and B, we just wrote it there. Okay, let's start from C. A intersection B. Okay, what is A intersection B going to be? A intersection B. A intersection B is equals to 6. Okay, we have curly bracket, 6, 12, and 18. What about next one? A union B. Let's see. A union B is equals to, okay, so we have a bunch of stuff here. 2, we have 3, we have 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20. Okay, we wrote those. Now what about A complement? What about A complement? What about it? Let's see. Let's see what A complement here. So if we want to erase this, we can. So A complement. So A complement is going to be all the others except for A, right? So it's going to be all the others except for A. That means we should avoid this circle. We should avoid this circle and do the others. Right, so let's see. So A complement is going to be, must avoid this circle and do the others, right? So it's going to be 1. Okay, just don't think about the order. Just don't think about the order. Just write with 1, 7, 13, 17, 19, 11, 5, and then again 2, 4, 8, 10, 14, 20, 16, blah, blah, blah. You can do that as well like that. And then, yeah, you can erase that. Okay. The same thing you can do with the B complement too, right? So, yep. So that is going to be the end of this question as well. So this is actually a good question. Actually, it's a good question which has all round properties, because we have like it's covering the entire thing that we learned in grade 9, right? Okay, so see you in the next question, I guess.